Hi, everyone. Mr. Geisman here. We're going to be going through our lab for today, which is the measuring using the metric system lab. So we're going to be following along, trying to keep it as close to what we do in class today. And we're going to be putting the answers on the board behind my head here. So as you can see right up here, all right, we're going to be starting with one floor tile in millimeters, all right? So I'm going to show you one floor tile with a meter stick on it. Let's see if we can get this one. All right, so we've got one floor tile here in with a metric meter stick, and it gets a little blurry, but I want you to do your best. What value is that line at on the meter stick, right? Give me your best answer to how long that floor tile is. So hopefully you saw that our floor tiles are about 30.3 centimeters long. So that gives us a pretty good start. And now we need to make the conversion. And we know that there are 10 millimeters in every centimeter. So what we need to do is we need to multiply this number by 10, and we get our answer of 303 millimeters in each floor tile. The next thing is we want to know how many centimeters or how many meters are in 3 floor tiles, right? So how many meters in 3 tiles? Right, so how many meters are in 3 tiles? So hopefully you figured that out, and we start by taking our distance, right, 30.3 centimeters, and we want to know how many are in 3 tiles. So we multiply that number by 3 to give us our first piece of 90.9 centimeters. All right, 90.9 centimeters. Now we can go from there and we can convert. And we know that there are 100 centimeters in 1 meter. Our units cancel out. 90.9 divided by 100 gives us our answer of 0.909 meters. All right, our next step then, we are going to be estimating the length of the room. All right, so in our classroom, there are 42 tiles from front to back. How many meters is that? Okay, so figure out how many meters are in 42 tiles. So hopefully you figured this one out, and you took the 42 tiles that we started with, and then you multiply that by our 30.3 centimeters per tile. That gives you an answer of 1,272.6 centimeters. But we want our answer to be in meters, right? So what do we need to do? We need to do a little bit of conversion. So to get our answer from centimeters to meters, we take our answer of 1,272.6 centimeters, and we convert that into meters. So we want 1 meter up top and 100 centimeters down below, because there are 100 centimeters in 1 meter. Our units are able to cancel out as we divide, and we'll divide 1272.6 times 1 divided by 100, and we get our answer of 12.726 or 73 meters. So our answer is 12.73 meters. Our next step then, we're trying to figure out the length or the width, of a tabletop. So a tabletop in our class. So what we did is we took a meter stick, and I started at 10 because the zero end is a little chewed up and hard to read. So I made sure that the 10 was right there on the edge, and it goes all the way to 71, almost exactly. So what is that distance, all right, or the width of our tabletop? Figure that out. So hopefully you're able to do that math and take 71 centimeters minus 10 centimeters to figure out that our actual length is 61 centimeters. So the width of that table, all right, the distance of that table is 61 centimeters. But we want this answer to be in meters. So what we need to do is we need to take this answer of 61 centimeters and convert that into meters. To do that, we use dimensional analysis, and we know that centimeters will cancel out, and we're left with the desired unit of meters, which is great. 61 times 1 is 61. 61 divided by 100 is 0.61 meters. And that's the distance or the width of our tabletops in meters. So the next section of our lab is going to deal with figuring out the mass of different objects. And we're going to start by figuring out the mass of this rock. So we're going to put this rock on the scale, and we're going to adjust the riders or the sliding weights here until we get a balanced balance. Now, right now, it's not enough. And this is as high as our scale will go. Our scale can only go up to 200 grams, and we've already reached that limit. So what we need to do is we need to add a mass to this side of the scale. This mass says on it that it's 200 kilograms. All right, so we're going to add 200 kilograms to whatever our mass is going to be once we figure it out. So we're going to take our sliding masses or our riders. We're going to keep on moving them until the balance begins to tilt. Okay, so we've gone too far. So we know that it is somewhere in the 140s on our riders, and we adjust our smaller mass riders or smaller sliding weights until we get to the correct point. You can see that needle is almost there. And that looks pretty good. So remember, we have to add the 200 grams from the counterweight to our number, and then we have to put together these two numbers. So it's a little difficult to see with the webcam, but where is that number? What is the mass of this rock? So add the 200 to the mass you see on the riders, and that is the mass of our rock. So our next station is we're going to be finding the mass of this small wooden block. So I'm going to adjust the riders or the sliding masses here. Until we are even. So I think we're a little bit past it already at 10 grams, but we're really close. So I'll put that back, and now I'll just adjust this rider until we get close to our balancing point. Remember, it was right around 10. And was just a little too much, so we should expect it to be just under 10. And that looks pretty balanced there. So, where is that rider at for this question? What is the mass of this block? So our next one is we're going to be using this 20 gram mass. It says 20 grams right on there, and I understand that it's hard to focus on that. But we're going to put that 20 gram mass on our balance. And we're going to see how close it actually is to 20 grams. And over time, sometimes these masses can lose a little bit of material from erosion. But it seems that mass is pretty close. So would you agree that the mass of this little weight is 20 grams? Do you agree that the mass of this is almost exactly 20 grams? So for our next one, we're going to take a float, that's what this is called, and we are going to fill it with 45 grams of salt. Now, the trick with this is we have to account for the mass of that float. So I need to figure out how much this float weighs. And we're right around it. That our float weighs, it's difficult to see, but 2.35 grams. So what do we need to do with our float or with our mass to make sure that we get 45 grams of salt onto our balance? What do we need to have this adjusted to in order to figure that out? So hopefully you figured out in order to find our 45 grams of the salt, we need to adjust the sliders, the riders or the sliding masses to 47.35. That accounts for the 45 grams of salt and the 2.35 grams that takes up in the float. So how do we do this? Well, we take our salt and we can start by pouring in a little bit of the salt. Otherwise, we'd take a really long time to find the weight. Now what happened was we put a little too much in. We can now take our tool and we can start removing salt until we find the right balance. We're getting close. Just a hair too much over here. So I'm only going to take a little bit, try not to spill it on the table, and we can get that to balance. So now we know that we have 45 grams of salt in the float. So the last part of the lab that we're going to look at today is we're going to look at finding the solid volume of cube number 1, cube or bar number 2, and then this empty bottle. All right, and we're going to assume a few things. Now I'm going to give you some information here, and we're going to figure out the density of these things. So the last piece we're going to be looking at are the volumes and densities of some blocks. So block number 1 has a length of 6.3 centimeters, a width of 3.9 centimeters, and then a height of 1.9 centimeters. From those numbers, please figure out the volume. Okay, by taking the length, width, and height and multiplying those 3 together, you should have gotten a volume of 46.68 centimeters cubed, because we measure volumes in centimeters cubed of solid objects. The next thing we're going to do is we're now going to take that volume and we are going to find our density. And remember, density is equal to mass over volume. We already have our volume right here, and I'm going to give you the mass. The mass of block number 1 was 30.4 grams. From those two numbers, figure out our density. So when you take our mass divided by our volume, so you take 30.4 grams divided by 46.68 centimeters cubed, you get an answer of 0.65 grams per centimeters cubed. We would do the same things for block number 2 and for the bottle, but that is where we're going to wrap it up today. All right, so that is our lab. Be ready to do conversions like this on our test. Have a great day, everyone.